Let's get started on packet structure and protocols. In this section, we will discuss the following topics. What is a packet? What is a header? What is a field? And what are common fields? What is encapsulation? Which protocols add which fields? And what is protocol analysis? So let's start out with what is a packet. A packet is a message which is sent from one computer to another computer. And a packet has two main components. The data which is being sent, in this example, ABC, and the header. And what the header does is it specifies where the packet is going to. The header specifies the destination IP address, which is the computer that it's going to, and the port number, and the port number refers to the program that it is going to. What is a field? A header is divided into fields, such as destination IP address and source IP address and port number. So a field is a subset of a header. Common fields, which you are already familiar with, include destination IP address and source IP address and port number. But there are other important fields as well, such as the Timetolive field, the Acknowledgement number field, window size, checksum, and protocol. So let's briefly look at some of these important fields. The first one to discuss is the Timetolive field. The Timetolive field is a field which is used to count the number of times a packet has crossed a router. And it has two purposes. One, to calculate the best path in hops from one computer to the other, and to prevent endless looping, to prevent the endless looping of a packet being forwarded from one router to the next router to the next router. The Timetolive field works this way. Each time the packet crosses a router, it is decremented. Now, what do you mean by decremented? It means subtracted by 1. So, in this example, if the Timetolive field starts out at 16, it is reduced by 1 each time it crosses a router. This is called being decremented. And when the Timetolive field becomes 0, then the packet is discarded. So, two purposes for the Timetolive field: to calculate the best path based upon hops and to prevent endless looping. Another important field is acknowledgement number, and the purpose is to allow a receiver to send acknowledgements to a sender. And one method of acknowledgements is for the receiver to send an acknowledgement for every packet which is sent by the sender. So the sender sends a packet, the receiver sends acknowledgement. Sender sends a packet, the receiver sends an acknowledgement. This is ping pong. And the disadvantage of having an acknowledgement for every single packet which is sent, it results in high overhead and almost doubles the traffic. A much more efficient way to go is, instead of sending an acknowledgement for every single packet, send an acknowledgement only after, for example, 10 packets have been received. So the acknowledgement number acknowledges the last packet which was received, and that results in less overhead. One acknowledgement per 10 packets instead of one acknowledgement per one packet. The window size is the maximum number of packets which can be outstanding until an acknowledgement is required. And the bigger the window size, the lower the overhead. Sliding window is a feature of TCP/IP, and what TCP can do is it can dynamically increase the window size. If it finds that it's not getting a lot of errors, it increases the window size, and that can result in significantly lower overhead. Another important field is the checksum field, and the purpose is to determine if a packet got corrupted in transmission. What is a packet but a string of zeros and ones, and any one of those zeros and ones could get corrupted during transmission. So a checksum is a mathematical algorithm, and here is a super simple example of what checksum is. The sender, when it sends a packet, adds up all the ones in the packet and puts that number at the end of the packet. Then the receiver, when it receives a packet, adds up all of the ones in the packet and it compares it to the number which is provided by the sender. And if those two numbers don't match, that implies the data got corrupted during transmission, so the receiver sends a negative acknowledgement to the sender and the sender resends. The purpose of checksum is to determine if a packet got corrupted. Another field is called the protocol field, and that identifies what is inside the packet. You usually think what's inside a packet would be user data, but a packet can also include Internet Control Message Protocol information, that is to say the ping command. Protocol shows what protocol is being encapsulated in that packet. A header is made up of fields, and some important fields include destination IP address, source IP address, port number, and time to live, acknowledgement number, window size, checksum, and protocol. Now let's discuss encapsulation. Encapsulation is the process by which protocols add fields to a message. We start out with the raw data, and then the TCP protocol adds port number, and then the IP protocol adds the IP address, and then the link layer, the Ethernet protocol, adds the MAC address. Encapsulation is the process by which protocols add fields to a message. So let's just talk about the concept of encapsulation in human communications. And here's an example. A boy writes a letter to his grandmother. That's the data. And then he puts it in an envelope. So the letter is being encapsulated in the envelope. Then the envelope is being put in a mailbag, so the mailbag is encapsulating the envelope. The mailbag goes in the mail truck, so you could say the mail truck is encapsulating the mailbag. And then the mail truck goes down the road, and at the other end is the decapsulation process. The mailbag comes out of the truck, so it's decapsulated from the truck. The letter comes out of the mailbag, so it's decapsulated from the mailbag. And when Grandma takes the letter out of the envelope, she is decapsulating the data from the envelope. Now let's look at encapsulation in the context of computer protocols. As we know, we start out with the data, transport layer adds port number, IP address, IP protocol adds the IP address, and the link layer protocol adds the MAC address. So let's take a closer look at the protocols and the fields in those protocols. Let's look at the protocols in TCP, UDP, IP, and Ethernet. Here is a simplified diagram of a packet header. We have a packet right here, and the data is ABC, and the packet header shows that we have destination IP address as well as port number. Well, a packet header has more than just two fields in the packet header. It has many more fields. This is just a simplified diagram. Here is a diagram of an IP packet header, and you can see, yes, it includes IP address, source and destination IP address, but it includes other fields as well, such as version, type of service, time to live, protocol, and header checksum. So let's examine the fields in the IP packet header, some of which we have already discussed. The first field in the IP packet header is version, and that specifies whether it's IP version 4 or IP version 6. The Internet header length field specifies the length of the IP header. The TOS type of service field is also called QS for quality of service, and it allows us to assign certain higher priority for certain packets, so those packets will get pushed ahead of the others. Total length field specifies the total length of the datagram, And the identification field is used when the message being sent has been chopped up into many IP packets. And the purpose of the identification number is it allows the receiver to reassemble those packets in the proper order for the message to make sense. The flags field includes don't fragment or more fragment flags. Fragment offset simply shows where the data begins in the packet. And the time to live field specifies how long the datagram is allowed to live on the network in terms of hops. Each router decrements the value of the time to live field, reduces it by 1, prior to transmitting it. If the TTL field drops to 0, the datagram is assumed to have taken too long and is discarded. Then the protocol field specifies what's in this packet. Is it TCP/IP, which is user? Is it TCP, such as user data? Or is it ICMP, such as ping? The IP header has the checksum to check for errors in transmission. Of course, it has source IP address, destination IP address, and options. And padding is whereby if there's not enough data to fill out the minimum size of the IP datagram, it adds extra zeros just to pad it out so the datagram will meet the minimum size. And of course, data is the data which is being sent by the user. Now let's look at a diagram of the TCP header. Now we've already discussed that TCP specifies port number and acknowledgement number, but let's look at some of the other fields in the TCP header. It starts out with source port and destination port, and we all know that port number, such as port number 80, was web traffic. And then sequence number and acknowledgement number are used to send acknowledgements between the sender and the receiver, so the sender knows the data is getting there. Data offset specifies the number of 32-bit words in the header. Reserved bits reserved for future use. We have a field for control bits, such as the urgent bit, or the acknowledgement bit, or the push bit, the reset bit, the resynchronized bit, or the finish bit. And the window field specifies the maximum number of packets that can be outstanding until an acknowledgement is required. The bigger the window, the more efficient the data is going to go through. Checksum is used to check for errors in transmission. Urgent pointer specifies if the data is urgent. We have additional options. Padding is used if the data is not big enough to fill out the minimum size of the datagram, so it just adds zeros so it'll meet the minimum size. And of course, the data is the data which is being sent. That was TCP. Now let's look at the fields in the UDP header. Now UDP is very similar to TCP, it just does not perform acknowledgments. The UDP header, of course, has the source port and the destination port, port number 80 being web traffic, the length of the entire datagram, checksum to determine if the signal has got corrupted, and the data which is being sent. But notice there is not a sequence number and acknowledgement number because UDP does not do acknowledgments and error checking. So now let's examine the fields in the link layer or the network interface layer. And two examples of the link layer or the network interface layer would be token ring or Ethernet. We will look at Ethernet in this example. In the Ethernet format, of course, you have the data, and that's the data which is being sent. And then also the Ethernet adds the destination MAC address and the source MAC address, and this 7-byte preamble, it just shows a string of 56 ones, which just says this is a brand new packet coming in. It just indicates that that is the beginning, marks the beginning of the packet. Encapsulation is the process by which programs add fields, protocols add fields to a message. TCP adds port number, IP adds IP address, Ethernet adds MAC address, as well as other fields. Why do we care about packet headers? The reason is because we use them in protocol analysis, whereby we examine packets. When we do troubleshooting with a protocol analyzer, we can determine the packets which have been sent, we can verify the source and destination IP addresses, and we can look at the port number. Wireshark is a protocol analyzer that's used to capture and view packets on a network, and you can access CCBC has a Wireshark protocol analyzer located on our VDI, our virtual desktop infrastructure. And we can see that Wireshark is the world's most popular network protocol analyzer. And to start a capture of packets, we click on Start, and then it captures packets. And you can see here is a packet right here which we have captured, and it shows the source IP address is 72.21.91.29. Destination IP address is 10.0.0.7. The protocol is TCP. It is sending an acknowledgement. There is the secret number, the acknowledgement number, and the window size. Wireshark is a protocol analyzer that allows us to look at the contents of the packets and the packet headers. In summary, in this section we looked at what is a packet, what is a header, what is a field, and what are common fields. We looked at what is encapsulation, which protocols add which fields, and what is protocol analysis. The assignment is to connect to the CCBC virtual desktop infrastructure and to start up Wireshark and to capture packets, and then to ping the default gateway, and then to see if you can identify the source and the destination address of the packets which are being sent to the default gateway. And this concludes our section on packet structure and protocols.